Hello, my name is Alejo Leonardi. I'm a sales consultant for the global solution business. So today I'm going to talk about assembly process control, okay, and how Atlas Copco understands this concept. We have talked about that previously. We talk about then how this is a solution for the product recalls. Now today we're going to dig in a bit better or deeper into the understanding on what assembly process control is. So maybe you can, this simple graph will tell you about the challenges in the assembly. We talk about the symptoms. We talk about that symptoms are caused by a problem, and of course that problem has multiple root causes. So let's take one example. Field claims. Whoa, okay, that's a big one. Yeah, of course, it's a big one because field claims cost a lot of money, okay, to the customers and create a huge negative impact in the image of the customers. Now, let's analyze this field claim. What was the problem? So in this field claim, the problem was, as it says there, a missing tightening. For any reason, we need to discover, the customer will need to discover they had a missing tightening. So they start analyzing and digging in and say, okay, could be caused by an untrained operator, could be an infrequent model, that is not so often, so then the operator got misled or confused, and then he simply forgot or she simply forgot the tightening. Could be that the wrong tool was used, of course. Could also be that the wrong bolt for that operation was used, and then it didn't fit, and then the operator just left it like that. And could be that then that was the reason of missing. Now, how do our customers analyze these problems? So you might have heard about 5M or Ishikawa analysis or fishbone analysis. So this is different names for the same. And they took five areas where they can find a problem. Now, let's analyze and then just go quickly through that. And we will use this same analysis to show how Atlas Copco process control can help our customers. So first is men, the person that was doing this. Who did it? When was this done? That is a portion of the analysis that the customer might want to do. They want to know maybe what the machine they were using, what was the configuration, was it calibrated, was it the right machine for that operation? That could be another root cause. The material that was used, did we have the right part in there? Did we have the right bolts? Are we using the right material for that specific model? Okay. The method, were we using the right sequence in this one? Did the operator follow the instructions? For example, there you see he has the written instructions there. Was he looking at that? Did he use that method, or maybe he used different steps, and that's why we missed that tightening? What was the medium? Where this error come from? Which station? Okay, which environment? Which line? Can we understand a bit better why in this line they had that problem and not in the other line? So that's let's say a basic analysis of the 5M. Now let's bring that into our words and how Atlas Copco understand this in a better way. Okay, so now we will analyze these 5Ms. Let's start with man. Okay, who, when. So we have these three operators. Okay, welcome, step in. Thank you. So these three operators, they're working on these three different shifts. If we are really controlling the process, we will know exactly who was working at the time of the error. Was this an operator that was trained for that operation or not? Was he doing this in the right station at the right time? That we can do with a really process control on the operator. So only one of you was supposed to do that, okay? The rest not, so thank you. Let's continue now with the analysis. The machine. Which machine are we using? What you see here in the image could be three tools. Yeah, of course. Maybe you say, yeah, those tools are not similar. How can they get confused? Maybe not a battery tool with a click wrench. But what happens if it's in a repair station and they have all click wrenches? They are all quite the same. Couldn't be that they are choosing the wrong one. Could it be that maybe if there are different tools, okay, but they are selecting the wrong parameter? Could it be that it's the wrong batch count for that one? Maybe. Now, if we have a process control that really make sure that the right tool is selected, the right tool, only the right tool is enabled. All the other ones are locked. They cannot use it. So that's how we can avoid then mistakes related to the machine. Now, what happens when we have so different material, okay, or analyzing the material. So, okay, we have the three engines here. Okay, these three engines are three different models. Okay, one of them maybe doesn't come so often, or they are really quite similar, and we could really get confused. And then we need to mount the right alternator on this. Okay, so we have the three alternators. Okay, perfect. Now, which one is the right for that? So if I don't know and I don't have any kind of control on this, maybe I choose the wrong one. Okay, for that one that doesn't fit. Okay, or let's say maybe the operators are well trained and they know which alternator it is. So okay, it's this one. Okay, they know that one. Now, what happens if the supplier, okay, send a batch that had an error in that? So if we're controlling what we're mounting on each of these engines, if we're tracking and tracing the serial number of each alternator, okay, into these three engines, then later on, if there's a problem, we can know exactly which engine do we have to repair. Okay, so that's a simple way to control really the process, to make sure and trace it later on to minimize the effect when we have a mistake or when the customer has a mistake, maybe not from themselves but from the supplier. Now let's continue, okay, with the method. So I mentioned this briefly before. With a really efficient process control, we can interlink different processes, different steps in the right sequence. So let's say here we have first we need to do a mounting of the alternator, choosing the right one, then we need to do the tightenings, and then maybe we have another tightening afterwards. So we need a really good process control can make sure that this sequence is followed and not enable the next step if the previous one was not done correctly. Or let's say maybe not in the same station, but what if we are doing, for example, a hot test or a cold test in this engine, and the previous station, if we don't have an OK on the tightening of the previous station, then we shouldn't be able to run the cold test. Let's not lose time because that other thing was wrong, that other process was wrong. So that's what I'm referring to when we really control the method, okay, that we are sequencing. And remember, this is not only about tightening. We're talking about other processes that our customers need to do, and we want to control, we want to interlink them all together. Finally, the last M is the medium. So let's say we have an error, and we want to know exactly which station comes from. Or let's say we are controlling the process on a rework station. Okay, and on that rework station, then we have the results coming from different stations. We want to really control from which one is coming. We want to know that, we want to trace in order to avoid, okay, that this mistake is done again on another station, so on and so forth. So now we completed the 5 M's, but we have something extra here that I would like to point out. So what is this actual versus target? Okay, so let's analyze again. We continue with the engine production. So again, here we have an engine. So what is the process that we have to do in this engine, in this station? It's we have to do 5 tightenings. Now, if we don't have a process control, then and let's say we have a traceability system, maybe the customer traceability system, the quality system, it could be even our own toolsnet, okay, that then we see a list of the tightenings that were done in there. And then you see, okay, we have here 3 OK tightenings and 1 NOK. That's all we see. But what happens? This gray one here, okay, that gray one there wasn't done. And if we have just a traceability system that is not really controlling the process, then we will miss that. Now, what happens if we know what was the target of that engine? If we know that we were supposed to do 5 tightenings, or if it was not tightening, if it was 5 processes, that we know exactly what was done and what was not done at all, then in that case we can detect that missing tightening, okay, and we can tell the operator, we can tell the system, hey, point out, we have a missing tightening here, okay, and we can repair that and avoid, for example, in our case, that a missing tightening leaves the factory, okay. So I hope that's clear so far. Let's move on a little bit on how to show how then Atlas Copco solutions can help that. Okay, that was a bit theoretical. Now, what do we have to offer our customers directly? Then I will focus on error-proofing solutions. And now I'm focused on this, but remember, Atlas Copco has a lot of products that can support on the process control of the assembly. Now, error proofing is just one of those solutions that can bring many of those points together. So here we have an SQS3 running on the station, as you see there, and of course we have operator guidance. But remember, SQS is not just operator guidance, it's really controlling the process. Operator guidance is what the operator sees on the screen. That's it. So it's guiding the operator on the steps, but on the background, the system is really controlling the process, okay? Interlinking, for example, an integrated digital I/O device. It could be a PLC, for example, through a digital I/O connection. Could be maybe this picture light that is shown there on the image. That I'm controlling that I'm using the right bolt, okay, for that engine. Now, of course, as I said before, we want that the system controls the user identification. SQS does that. It even has, so the industrial PC has an embedded RFID reader, the AC node, for example, and then you can directly identify the operator. So before starting a process, make sure that the right operator is there, okay? I also mentioned about the tool interlock. Of course, we're controlling the right tool, the right parameters at the right moment. We're doing part verification, part documentation. Okay, the system is able to control that and verify that the right part is being mounted, and also document and trace that for later on. Where? On the data collection. Of course, we want that our system collects all that data and it's able to utilize later on to improve the process, also to control that nothing is wrong afterwards. Like I said, if the supplier from the alternator comes and say, hey, this patch was wrong, then I have on my data everything to make sure that I detect which engines have that problem. Then let's not forget about the service package. Okay, we want to make sure that this is correctly set up. We want to make sure that we are delivering all the values, okay, that the solution can offer to our customers. And we want to make sure that this is maintained in time, okay? We want to make sure that when there is a new model coming in, we want that this software keeps running, okay, in the right way. We want to make sure that, as I said before, we deliver all our promises to our customers. And then in the case of SQS, then it's scalable. Okay, that's quite nice of it, that we can start on one station, the customer can start checking and controlling this on a station level, then maybe on a cell level with more devices interconnected, then to a line, complete line with a rework at the end, control the complete plant, multiple lines in parallel, and why not even globally, that the customers and the headquarters and the tech centers, they can check that all the results are accordingly in the right way, and that if there is a problem on this plant, on that plant, that we make sure that this information is shared. Okay? So, wrapping up, let's go through the 5 M's and see how did we sort that out. Okay, now we have this station, we have process control from Atlas Copco. As I said, we know who's doing that, and we know when he's doing that. All this is recorded on our database. We know which machine. We're controlling really that the right machine is used at the right time with the right parameters. Okay, we know the right material is used, the right bolts, the right parts. Everything is according to what is specified. We control the method, again, the process, the steps. Okay, we make sure that this is according to what is specified. Finally, the medium. We know exactly, and we're tracking where an error comes from. Okay, and we know when we're on a rework station when this problem comes from immediately. So that's it. I hope you enjoy that. I hope that this is valuable for you, and see you next time.